Yeah, hello and welcome to today's GFG problem of the day. Hope you're doing well. Let's see today's problem, K-Pangrams. So what the problem is saying is, we'll be given a string, okay, a string and a K. And what we want to find out is whether the given string can be changed into pangram, okay, with at most K operations, If it is not possible, then we have to return false. Now, first of all, what is a pangram? A pangram is a string which will contain all the alphabets basically, and those alphabets can be repeating. For example, a, this can be repeating, right? B, C, D, E, and all the way till the string should be having all the alphabets from A to Z. And the string may have duplicate characters, like as I said, right? A or B, any character can be duplicate, but every character, every alphabet should be present in the given string. So that string is called pangram. Okay, now what we want to do is, will be given a K. Okay, now what we can do is, we can replace at most K characters in order to make the string pangram. Okay, so let's see an example. Okay, let's see an example. So if the given string is this particular string, okay, if the given string is this, so what we want to do is, let's see whether pangram is possible out of this string or not. Okay, now in order for a string to be pangram, first of all, it should be having alphabets greater than or equal to 26. Okay, greater than or equal to 26, then only we can change, that particular string into pangram. That is first condition. Second is, definitely the and also the number of replaceable characters should be less than equal to K. Okay, should be less than equal to K. So that's what, right? We can do at most Q operations. So let's quickly see how we can solve this problem. Okay, so the expected time complexity is O of n and space complexity is O of 1. Okay, O of 1. So what we'll do is, we will go through this we will go through this string, we'll iterate through the string, and we will have an ASCII array. Okay, and what we'll do is, we will place these alphabets, right, the given alphabets into this array. Okay, so what we'll do is, we'll put A into 0th position, B into first position, C into second position. Okay, so that's what we are going to do. So for example, let me also write the code. So let's write int. Let's say the array name is, ASCII array name is ASC. Okay, now what we'll do, we will iterate through the string. Okay, 2-char array. Okay, so first I'll show you the Java code followed by C++. Okay, now first of all, the string can have either alphabets or space. So first of all, we'll say, if there's a space, we'll simply ignore the space. Okay, we'll simply ignore the space. We are continuing. Now what we are saying is, now we'll put the characters into the array. Okay, so how we'll put, so whatever is the character, minus A, minus the ASCII of the character. So what does this mean? What does this mean? So whatever is the character, for example, if it is C, right? So what we're doing, we are subtracting the ASCII of it. So what this will give me? This will give me 2. Okay. Okay. So let's say the ASCII of C is 99, right? And A is 97, right? A is 97, C is 99. So what we are saying is, we are subtracting 99 from 97, which will give us 2, and which the position of C will be this. Okay. So that's what we are doing. So we are placing the characters in their right position. Okay. Along with this, we'll also maintain the character count. Okay, character count equal to 0, for example. Okay, so what we are doing is, we are keeping track of the alphabet count. So this, as I said, the string can contain a space or alphabet, right? So if it is not a space, we'll increment the character count. Okay, so this is done. Now what we'll do is, now we will iterate through this ASCII, right? For example, if we iterate through this string, right? Now this string length, or this character count, right? Character count, whatever we got here. So it is 26. Okay, it is 26 character count. Now what we're going to do, as we iterate, right? So we are going to place A into the 0th position, right? So we'll keep on incrementing. So here, finally, after, it will have 26. Okay, as a in the first position. Okay, after we do this operation, so this array will contain 26 characters. Now what we're going to do, we are going to iterate through this array. And uh, and we are going to count the the missing characters basically. So let's see. Let me introduce a variable cnt. Okay. What we're doing here is we will now int I equal to 0, I less than 26, right? Plus I. Okay. Now, what we'll do is if we'll say if ASC of I, if it is 0, right? That is the characters missing in the string, right? That is the characters missing, we'll increment the count. So that's what we are doing here. So here, when we do this operation of checking the missing characters, the missing characters will turn out to be 25. Because if you see, right, all these will be 0 except for this particular, the first position. Okay. So we have taken the count of the missing characters, right? We have taken the count of the missing characters. Now what we'll do? Now we'll say if CNT is less than K, okay, that is K needs to be greater than the missing character count only, right? K should be greater than the missing character count. Only then we'll be able to replace, right? Only then we'll be able to replace B, C, D. Okay, we just have to tell the possibility whether it is possible or not to convert this string into the pangram. Okay, so that's why K needs to be greater, or we can write in this way. K needs to be greater than the missing character count. Okay, what count? And the size of this char count, right? This one, right? Char count has to be greater than equal to 26. Why? Because as I already said, right? So a pangram is a string which contains all the alphabets, right? So that is why in order for a string to be converted into pangram, at least its alphabetical count should be greater than equal to 26, right? Then only we can make it pangram, right? So that is why this condition. Okay. Now let me quickly submit this. Let me compile this. Right? Let me submit it. So yes, the test cases are being processed. Yeah. So the cases are passed. Thanks for watching. I'll request you to subscribe to my channel, like the video. Let's quickly see the C++ code as well. Oh, okay. So I won't show you the C++ code today. I had implemented, but somehow it has disappeared. So it's almost same, right? It's almost same. You just have to like, there'll be few, like for example, right? The built-in functions, it is going to be different, right? In C++, but almost it is going to be the same. So I won't show you the C++ code today. Yeah. So this is it. I hope you have got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.